Hello guys, this is my second tutorial on Numpy. In this part we will start exploring through each and every method in Numpy. To start with, we'll take our first method, which is finding the maximum of an argument. Using this method, we can find the indices of elements representing order of data. To do this, we need to have an example. So I will take array method to create an element. To start with, we need to import numpy, and I give a alias name np, and I want to create a array, so I will type array, and I will fill it with the elements. So I want to create a two-dimensional matrix, so I will give 2 square brackets, and I will fill my first row with element 1 by 3, and I will keep the second row as 10 1 2, and I'll keep my third row as 10 30 and 20. I should close my second dimension. Alright, so I have filled my elements. Now I want to have a data type for my elements. I specified data type as int 64. Now this has created me an array. The array A, you can see it's a two-dimensional array with 3 rows and 3 columns, and the elements has a type int 64. Alright, let us start with our first method. So using argmax, one can get the order, so one can get the maximum of the order of elements in terms of indices. So yeah, you can find the indices of elements across different dimensions. You can find indices along axis 0, along axis 1, which is rows or columns. So let us give the name of the object as argmax, and we say axis 0. So this is along row, and then we say method, the method name is argmax. The first element of the method is your object, which is A. So we will find, so okay, let me write this first, method A, and then we say axis equal to 0. Now we'll check the answer for this argmax axis 0. So let us see what we got. Along axis 0, for the first column we have 1 10 10. So the maximum element is 10 in position 1 and in position 2. To solve the equal solution, this method chooses the first maximum element. So the first element you can see is 1. Similarly, we expect 2 in this case because indices is 0, 1, 2, and similarly 2 in this case. Using the same way, we can find the argmax along axis 1. So we need to type axis equal to 1. Now this we will find along this dimension. So what we expect is 1, and then we expect 0, which is the maximum, and then again I expect 30, which represents the index 1. Now this is how you can find the maximum along a given dimension. Similarly, you can find the minimum of an argument. So you just need to type argmin. We'll start again with axis 0, and then I replace argmax with argmin. Axis 0, and I say argmin. So let me type A first, and now what we expect from argmin axis 0 is, so first of all I want to find the minimum along this dimension in 1 10 10. So I expect 0, then I expect 1, and then I expect 1. Yeah, so this has given me the indices which is I expected. Similarly, you can do for x1, which is 0, 1, 0, and you can check it. The second method is to sort your array. Actually, there are 3 algorithms for sorting, namely heap sort, quick sort, and merge sort. We'll see the difference between all 3, and the method follows this. So you define your object sorted array along axis 0, and then you say, and you give the method name, which is argsort, and you want to sort your argument for a, and next thing is you define axis 0, and now this third definition is kind, and then you define the algorithm you want to use. So I say quick sort, let me clear the screen first. So sorted array along axis 0 is this, and your A is this. So axis 0 representing elements 1, 10, 10, and it has arranged from in an increasing order. So 1 is 0, then 10 is 1, and this 10 is 2. Whereas in second case, this is the lowest element, so this will be 0. This is the second lowest, and this is 1. And sorry, this is the lowest, and this is second lowest, and this is the last element. So in this way, it has sorted an element along a column. And if you want to repeat the same along axis 1, you just need to change your axis to axis equal to 1. And then this will do along elements 0, 1, 1, 1, 5, 3, 10, 1, 2, and 10, 32, 10, 30, 20. Which you can check from the figure now. And as I told, there are 3 algorithms for this. One is quick sort, another is heap sort, one is merge sort. Quick sort and merge sort are almost same, you will get the same result. However, when you check the merge sort, however, if you check heap sort, you find a difference in a way. So when you say heap sort, now if you check your sorted array, and if you say now, if you check the results with the previous case, it's same for the case where you are checking along row. However, if you come across this shape where you have to compare between 1, 10 and 10, and then this won't be 0, 1, 2 anymore like here, but this will change order. In this case, it will take the last element. If you have a similarity, it will take the last indices of the last element and put it above. So in that case, it will be 0, 2, 1. So we'll check on this using heap sort. And then I say x is equal to 0. Oh, it should be x is 0, but anyway. So now you can see the difference. It's 0, 1, 2. However, it is now 0, 2, and 1.